Today we will be covering Chapter 7 as it relates to anchoring. The knowledge objectives of this chapter are as followed. Describe the use of anchors in the high angle system. Identify potential anchor points. Discuss the placement of anchors. Discuss the positioning of anchors. Discuss the use of directionals, and explain how and why to back up anchors. Also, you'll need to identify and describe the materials used for anchors, describe how to keep anchors in place, discuss the use of anchor plates, explain what to do when no anchors appear to be available. There is one Rope Rescue Level 1 objectives, and that is to discuss the use of multipoint anchors. An anchor is a means of securing the ropes and other elements of a high angle system to something solid. The place where the anchors are connected is known as the anchor point, which can take many forms, man-made or natural or artificial. The most commonly used natural anchors are trees and rocks. Both have potential for failure. You should examine a tree and its root system for weaknesses before using a tree as an anchor. Also, boulders that weigh tons can be pulled over by the stresses of your anchor system. You need to pay attention and use good judgment when choosing an anchor in the natural environment. Anchors often must be established in structures in industrial and urban settings. Some examples of inherently weak structural features are vents constructed of sheet metal, flashing, gutters, and downspouts, brickwork like small chimneys, and fire hydrants and standpipes. Choose anchor points that are inherently part of the building's structure or specifically constructed to support high loads. Some examples are structural columns, projections of structural beams, supports for large machinery, and stairwell support beams. Newer tall buildings usually have permanently installed anchor points on the roof for window cleaning equipment. Some industrial sites will often have pre-engineered fall protection anchors over the entrances of confined spaces. Many devices such as portable beam clamps and removable swivel bolts can quickly be installed to existing structures. Artificial high directionals, made popular for wilderness cliff rescue, adapt well to create strong anchors. There are some less obvious anchors out there. Some of these anchors you will have to do some creative thinking. For example, you can use elevator and machine room housings, the roof drain holes, wall sections between windows and doors, and stairwell beams. When using some of these anchors, it may take up a good bit of rope. Make sure you're using edge protection on your corners in rough areas. Artificial anchors are specifically designed for creating anchor points or fall protection in places where no natural anchors are available. These anchors should be placed by a person with a great deal of skill and practice in their use. Regardless of the type of anchor, placement of secure anchors depend very much on good judgment, which is developed through experience and practice. Although their specifics may vary from place to place, all anchors share certain characteristics. If the potential anchor point cannot sustain the anticipated forces, it must be abandoned for another, more substantial one, or joined with one or more anchor points. Anchors so strong they were able to withstand any force the high angle environment can deliver to them are said to be bomb-proof. The anchor's ability to withstand the necessary forces of a system depends on a number of factors, including the condition of the anchor, the structure and nature of the anchor point, and the location of the force on the anchor point. Always consider the direction of pull on the anchor point. Try to set the anchors that are in line with the direction of pull. Also consider the effects if the direction of pull changes. Some anchors are rigged so that they are strong only when pull comes from one direction. If the direction of pull changes, the anchor could weaken and fail. The position of the anchor affects the high angle activity. Ideally, it should be close to and directly above the subject to be rescued. It is often desirable for segments of the high angle system to be off to a side to avoid rope cross or tangles. However, if the primary anchor is at an extreme angle, problems could arise for those attempting to manage the rope work. For example, they may have to make a wide swing on the rope or pendulum to reach their objective. A directional is a technique for bringing a rope into a more favorable position or angle. A directional, in some cases known as a deviation, can be created in many ways, and each method must be judged on its advantages and disadvantages specific to a given situation. In this example, if you anchor the rope to either of the trees, it would be difficult for you to reach the victim without a significant pendulum. All right, let's discuss these two examples here of directionals. As you can see in example B, they've taken a secondary anchor or directional, and as is illustrated in the red rope, tied a figure 8 and ran the main line rope through the carabine that was attached to that. There's an additional advantage to this approach in that the main line rope runs freely through the carabiner so that the exact position of the activity moves back and forth and the angle can change slightly. A less desirable method would be as shown in example C here. They tied a figure 8 in the main line directly over their victim attached to their directional anchor. The problem with this is that when the rope is moved to one side or the other, it imposes a great deal of loading on one anchor, but very little on the other. So there are some disadvantages in multiple ways that you can set up directionals. A directional is used to change the path of the rope using a carabiner or pulley attached to the alternative anchor. Directional anchors may actually anchor the rope mid-line. A deviation redirects the path of the rope from the anchor point to avoid potential damage from rope and edges or to improve access by persons using the rope. Deviations may change the fall of the rope through redirection, but they do not anchor the rope. Anchor systems present a number of opportunities for failure. Some causes of anchor system failures include uncertain strength of anchor points, failures in human judgment and experience, and equipment failures. Backing up anchors is a creation of redundant safeties. There are two primary methods for backing up an anchor as shown in figure A and B. The specific method for backing up an anchor system and the number of anchor points you need depend on the number of variables, including the condition of the anchor points, the nature of the high angle operation, and the load and stresses involved in the system. When considering the nature of the high angle operation, if both a main line and a belay line are used, for example, you should separate the anchor systems. If the main line and the belay line originate from the same anchor point, the danger exists of lines tangling or heat fusion damage to the rope if the rope crosses. The belay system would also have to be substantial enough to catch the fall, which means you would need a substantial second anchor. When thinking of load and load stresses involved in the system, these all vary in intensity depending on the ways in which the anchors are used. And some of these examples would be supporting only equipment versus supporting the weight of only one person, or creating directionals to create forces greater than the load, potential shock loads resulting from a fall or a potential system failure, rescue lowering operations, hauling system, and high lines. These are all examples of loads and stresses that may be put on your system or your anchor. Many of us are going to be limited with the amount of rope that we have available to use. An easy solution is to use your mainline rope and make an anchor out of it. You can then tie another knot like a figure 8 on a bight and connect it into the system. You then now have two systems out of one single piece of rope. This method is known as using the tensionless hitch. The tensionless hitch, also known as the high-strength tie-off, is wrapped around an object so that the friction of the wrap takes a load. Another example of the mainline rope used directly to the anchor point is anchoring with a figure 8 follow-through. This has less flexibility for making changes than the tensionless hitch and may result in greater stress on the knot. It may be preferred when lighter loads will be in place on the anchor system because of it being quicker to tie. Now this can also be used when the loop of rope cannot be placed over the top or around the ends of the anchor point, but must be tied around it. Webbing is a convenient material for anchoring. It is also convenient for making continuous loops as runners or slings. The advantages of using webbing instead of rope for anchors are that it is less expensive and there are fewer knots to learn. However, webbing cannot be tied into as many different knots as rope, and it does not absorb shock loading as well as most ropes. You can create a sling from a piece of webbing by tying it into a loop using a ring bend knot, sometimes known as a water knot, overhand bend, or tape knot. Presewn slings are quicker to use and there's less of a chance of tying the wrong knot when making a continuous loop. Several brands that can be used for anchoring are available and can come in a variety of webbing widths and lengths. Anchor straps are webbing links with D-rings sewn into each end where a carabiner can be clipped. These straps can be a quick way of setting reliable anchors. They come in two basic types, NFPA G-rated and NFPA T-rated. The heavy-duty ones, G-rated, typically have an end-to-end breaking strength of about 8,000 pounds. Some anchor straps have an adjustable buckle that can be adjusted to various lengths. Just beware that the buckle may slip with a force less than the strap's breaking strength. One of our challenges is keeping the anchors in place. There are several techniques for holding webbing in place on a vertical anchor point. It generally is good practice to tie the anchor on the vertical member as low as possible to reduce stress on it. However, with the strong enough anchor point, there may be certain conditions in which it would be advantageous to tie the anchor webbing up higher. There are several techniques for holding webbing in place on a vertical anchor. One is the basket hitch, shown in illustration D, and another is to tie the webbing around the anchor point in a girth hitch, shown in illustration A. The drawback to this technique is the temptation to clench the webbing back on itself. This should not be done because it puts potentially dangerous stress on the webbing. Anchor plates help organize the anchor rigging and prevent it from jamming. They can make various components easier to see and can make rigging of the anchor systems more accurate. Anchor plates are commonly used where multiple lines come together at one common point. For example, where multiple lines need to be clipped into a master attachment point or where multiple anchor lines are collected at one point. A sort of portable anchor that usually is available is an emergency vehicle. However, you must observe the following safety guidelines when using a vehicle as an anchor. Park the vehicle on a solid surface, set the parking brake, chock the wheels, and make sure that nobody is going to move the vehicle. Structural parts such as axles and cross members can potentially serve as anchors. Make sure to protect the rope or webbing from oil, grease, and exhaust systems. Parts of the vehicle you want to try and avoid is the bumper and tow hooks. A picket system is an alternative in a natural area where no anchors are available. Although a picket system can work very well when correctly rigged, establishing it properly usually takes a great deal of time. In addition, not all soil types can hold pickets securely. Loose, sandy, or muddy soil or snow may not hold well regardless of the number of pickets used. Pickets should be made of metal with good shear strength, such as cold rolled steel or high-strength tensile tubing or rebar. There are also pre-manufactured commercial picket systems available with some anchor plates. Pickets should be at least 5 feet in length so that the minimum of 3 feet are in the ground and a maximum of 2 feet are above the ground. When driving the pickets into the ground, drive the pickets at a 15-degree angle. Connect the pickets in each row by lashing from the top of the first picket to the bottom of the next picket close to the ground. Tension the lashing by twisting them with a stick 4 to 6 turns and drive the stick into the ground to secure it. Connect the main line by clipping it to the front picket. Multipoint anchors involve 2 or more anchor points. They are used when one anchor point is insufficient to withstand the anticipated forces, or when one anchor point is inconveniently placed. By adding multiple slings on a single anchor point, you can help prevent the collapse of an anchor system caused by the failure of a single item such as webbing, a carabiner, or improperly tied knots. This kind of system is used only when the single anchor point is absolutely secure, otherwise known as bomb-proof. There is no insurances at all in the additional webbing and carabines if the anchor point fails. It is good practice to back up single anchors with a second anchor. Backing up is essential when you have an anchor that is in the right position but not strong enough alone for the rescue load. In this illustration, the anchor point on the right is near the edge and in good position, but it does not have the strength to take the load. You may consider this a primary anchor. Behind the primary anchor and directly in line with it is a second anchor. The strength of the secondary anchor combined with that of the primary anchor will be enough to sustain the rescue load. To combine the two anchors, a rope or a sling is run between them. This connector is known as a tieback. Two things that must be kept in mind when using a secondary anchor. The secondary anchor must be as strong or stronger than the primary anchor, and the tieback must have no slack that would allow shock loading, which could cause both anchors to fail. Anchor systems often have inherent slack caused by the rope or webbing stretch and by flexing of the anchors. If such anchor systems receive shock loading, the elements could fail. One way to lessen the chance of shock loading is with a pretensioned tieback. A pretensioned tieback is a method of removing the slack in the back tie anchor system before it is loaded. Load-sharing anchors may be a solution if anchor points are at all questionable or are inconveniently placed. The simplest way to create a multiple anchor system for load sharing is to use two anchor ropes or slings of equal lengths. Run them from different anchor points and clip them together to a single point using one or two locking carabiners. The point where you clip the two lines together with the carabiners is known as a master attachment point. With a fixed load-sharing anchor system, the stress on the anchor points is equal only when the force from the main line pulls directly in the center of the angle. If the anchor points cannot sustain side-to-side force, the entire anchor system may fail. A load distributing anchor system can help prevent this problem. Some guidelines to follow when constructing load distributing anchors are as follows. Keep the angles small. Design the system so that as little drop as possible would occur if the anchor would fail. And do not use bulky rope or webbing, and adjust the system so that the knots are less likely to run through the carabiners when the system readjusts. Use Kevlar and Spectra in an anchor system only when you include shock-absorbing material somewhere in the system. Make all the anchor points in the load distributing system as bomb-proof as possible. When considering load distributing anchor systems, remember that the forces on the anchor points should remain distributed and shared by all anchors, whatever the direction of pull. And if any anchor should fail, the system should readjust to help redistribute loading on the remaining anchor point or points. It is also important to note that no anchor system can be made completely self-equalizing, and it is critical that all rescuers realize that load distributing anchors are not for casual use in rescue. Because of their complexity and potential for failure, these systems should only be used when there are no options such as load sharing or extending anchors. This concludes Chapter 7 in Anchors. Please take a moment to read the following 7 slides in summary. Thank you.